All right, so continuing with the theme of hydration here, electrolytes is a common talking point or kind of phenomena within the athletic realm. So it's commonly thought that you need electrolytes to really hydrate at your best level. And so last week we talked about different sources of hydration, and that electrolytes do have some added benefit, but sometimes this gets lost in translation or blown out of proportion. So we'll dig into the details a little bit and try to better explain the benefits, the pros and cons, or the lack of evidence for either direction in terms of supplemental electrolytes. So to start, what are electrolytes? We'll break down what electrolytes are, what they do in the body, and then we'll get into how they impact things like performance. So, first thing, what are electrolytes? So, electrolytes essentially, or by definition, are minerals with a charge. And so, this can be either a positive charge or a negative charge. The positive charged ions are called cations, and then the negative charged ions are called anions. So, the more notorious electrolytes are things like sodium, potassium, and I suppose to some extent magnesium. But the main two that I hear discussed among athletes are sodium and potassium. And so I don't know exactly why that came about, but those are the for sure the modern supplemental electrolytes are sodium, potassium, and then to some extent magnesium. And so then what do the electrolytes actually do for the body? They do quite a bit, and they're similar in my mind to micronutrients in that they have a wide reaching function. It's not like one specific thing that they do. Because it's a group of electrolytes are a group of different molecules. They have these unique responsibilities, but then they have a wide reaching, because it's an umbrella term, they have a wide reaching function within the body. So they help with things like fluid balance. So the effect that sodium has on the renal system with water retention. The impact that sodium also plays for things like action potentials and generating muscle contractions. And specifically within muscle contractions, you have the heart rhythm and the neural signaling that's happening there to trigger the heart rate. So effectively, if you throw out of alignment your electrolytes, you're going to throw off things like your heart's rhythm because of this kind of notion of neural excitability. So basically, what that means is the nerve has a resting, what's called depolarized state. So it's in a negative charge. And so then it becomes a positive charge when we get this massive influx of positively charged cations. So, for example, if you look at the chart on the right here, you see the blue on the right is sodium. That's a positively charged ion. When that rushes into the cell through these different channels, it changes the polarity of the actual cell, and so that change in the electrical charge of the cell triggers what's called an action potential, which then sends an electrical signal down the line, which ultimately results in a heart contraction. So, by throwing off the density of these different ions, you can actually change somebody's heart rate and rhythm. So, most of the time, supplemental electrolytes don't have that large of an influence on these things, but a lot of pathologies are kind of born out of the imbalance of these electrolytes. And then lastly, the bone health. So calcium specifically plays a big role in generating new bone. And so if you have any kind of a fracture, calcium plays a role with that, breaking down bone to then create newer, healthier bone. Calcium is basically the building block of a lot of that bone building process. So, for performance specifically, we can look at what are the different supplements that you can take. And so, like I said, the big three that I see discussed are sodium, potassium, and magnesium. And so, a lot of kind of supplement philosophy comes from the sweat concentration. And so, a lot of people will say, "Oh, well, you lose salt in sweat, and so you have to replace it. You can't just drink water; you have to replace the salt that you lose." And so the two biggest electrolytes that are lost in sweat are sodium and chloride. And to some extent, potassium is also in that conversation, but the concentration is much larger for sodium and chloride. And so in terms of like what you would have to replace, you can look at some of these. This is, I believe, the numbers on the left come from averages, they're normative data. But you see this wide range in sodium. And so we know that some people have more salty sweat or less salty sweat. And so that's why you get this concept where Gatorade's making these sweat samples where you're actually taking a sample of somebody's sweat and seeing how much sodium is concentrated within their sweat. So the sodium loss through exercise specifically definitely needs to be individualized. You're looking at one unique individual. You can't just give a blanket prescription and say, oh, everybody needs to take this much sodium. Obviously, if you're losing a lot more, then you should probably be replacing a lot more. Now, the problem comes in, well, there's kind of two problems here. One, the concentration in sports drinks are not usually sufficient to replace sodium. So if you look at things like Gatorade or Powerade or any of the Body Armor or whatever brand you want, sports drinks just don't have that dense of concentration of sodium. And so what we looked at last week was they're really good at replacing carbs and fluid loss, but they miss out on some of these electrolytes. So then you bring in some of these other brands where they're specifically targeting the electrolyte loss. And the two that I've put on the right here, just for comparison, are Liquid IV is the blue one, and then the gray one is LMNT, also known as Element. And so you can look at the sodium loss. If somebody's a heavy sodium sweater and they lose upward of 1,500 milligrams, they're going to need to take 3 of these liquid IVs. So if a box comes with, I don't know what they come in, 8, you're going to go through a box really quickly. It's going to add up. It's going to get pretty expensive for one, but then like you're also just drinking a ton of salt through this added like concentration. Like drinking one of those is pretty salty. Drinking 2 of them, my God, that's not fun to drink. Drinking 3 of them, yeah, good luck. And it's the same thing with the Element, where you get a lot denser concentration of sodium, and you don't necessarily get the flavor additives where you get the sugar or the caloric content, but you do get this 1,000 milligram dose of sodium. But even then, it might be half of what you need, depending on how heavy your sweat rate is, and that rate is typically per hour. So if you're a heavy sweater and you're going out there and you're playing a tennis match or you're playing a soccer match and you're out there for 2, maybe 3 hours, then you double and triple that high end, and you're looking at something 3K to 4,500 milligrams of salt. You're going to have to take 3 to 4 of these elements, and you'd have to do. So I think the number. There's a really good presentation on this from Kevin Miller. I believe he's from Texas State. But I think in Gatorade, his example, it was you have to drink I think it was like 17 liters or something like that, or 27 liters of Gatorade to replace the sodium loss in a tennis match. And it's like, yeah, put that in front of athletes and tell them, okay, drink up, good luck. You're not going to get that much sodium from hydration strategies. You're going to get it typically through your diet. You're going to get a lot higher concentration of every single one of these electrolytes through your diet. And specifically within the American diet, where you're eating a lot of processed foods, preserved foods. These things have added sodium to increase shelf life, which then increases the bottom line for these a lot of these nutrition companies or nutrition products. And so we don't really have a shortage of sodium. So I don't know where this notion it came from, where everybody needs to be drinking electrolytes. In fact, I would argue, and I think that like the epidemiology would argue that more people have too much sodium in their diet, and we don't really need to be adding dense concentrations, 1,000 milligrams, for example, in Element, even really in athletes that are sweating a lot. Specifically, we can look at their impact on performance, and what it seems like for the most part, none of these really make an impact if you're taking them during exercise. They have really little impact after exercise. Like maybe there's some benefit of hydration and rapid hydration if you're doing back-to-back training sessions, but for sure, like while you're training, there doesn't seem to be much benefit. There's Brett Singer has given many presentations on this, but his kind of talking point is we have so much research on sodium specifically, and we've done all kinds of different tests. We've done endurance tests, we've done sprint tests, we've done jump tests, we've done high sweat tests. Like, we've done literally everything. And he's like, yeah, it doesn't impact performance hardly at all. We're spending way too much money due to marketing and partnerships or whatever else. But we're spending too much on these things that don't really move the needle all that much. And his argument again is, if we have all this information on the largest concentration that's sweat out, sodium, then he doesn't believe, and I think I'm in agreement with him, if that one doesn't make a difference, then potassium and magnesium for sure don't make a difference. So they don't really seem to be necessary for performance. The only real argument, like I said, is um, if you are trying to rapidly replenish fluid loss, and sodium can help you with that water retention. So maybe after training or after a game, if you have something the next day and you want to try to increase your hydration, maybe that impacts it a little bit. But even then, it's like, you can probably get sodium from better sources, or more dense sources like food. Now we can look at the impact of these different electrolytes on things like cramping, because that's another common talking point for um, performance, is that if you're in an endurance event, you're going to have things like cramps. So even in American football, where you have plenty of rest, there's a lot of cramps that happen. Basketball, there's cramps that happen. I think LeBron James cramped in, what was that, 2012 maybe final. I think it was against San Antonio, and he cramped in the fourth quarter and just physically couldn't come back. He tried to, but couldn't come back. And so it happens in all sports. Soccer, it's a pretty big one. There's a lot of substitutions that happen because people cramp and they just can't keep going. And so it happens in all sports. But what is the actual impact of these electrolytes on cramping? Well, there's also been a lot of research on this from Kevin Miller, like I said, out of Texas State, and there's not much correlation with cramping from these different electrolytes. They've looked at historically, they've looked at things like sodium, or sodium serum concentration, where you look at somebody's blood work and you see how much sodium is actually in their blood, and that's the most accurate way of measuring it. And there's no difference on these different sodium concentrations whether or not they are likely to cramp. And the same goes for magnesium and potassium. Like, there's really low correlation with cramping. And so it doesn't look like, if you're supplementing with these different things, that it's going to change your performance in either endurance or strength or power or cramping, or pretty much any metric that you want to look at. So these things kind of seem like a waste of time and energy and resources. For the literature review for this week, the American Heart Association gives a breakdown of what electrolytes are and how they impact the body, but then also break down kind of the downside risk of if you're taking too many of them. Especially long term, the risks there for things like hypertension are a big risk, and especially, like I said, with the American diet, where we're already over consuming sodium, adding these supplemental electrolytes to our diet probably going to come with some downside risk. So Cleveland Clinic also talks about the downside risk and what the health consequences are for these electrolytes. My Sports Science has a pretty good article talking about how much do you sweat, and then also breaking down sweat concentration. So it's a really easy read, but gives a couple of references and citations for accurate information. As I said, Dr. Kevin Miller has a great YouTube video. This was actually, I saw it first on a NATA publication. It was on like their continuing education platform. And I literally recorded like probably 20 minutes out of, I think it's like an hour long presentation. And I recorded so much of it just to have clips of what he was saying. And I would show it to athletes that I was working with. And it was just like, this is an amazing video. And it was actually published on YouTube for free. So everybody should go check that out. And then the second one has Kevin Miller as a featured guest. The Melbourne Athletic Development Physiotherapy channel has a video called How to Stop Cramping. And there's really, Kevin Miller breaks it down quite well. That's kind of his specialty or area of expertise, but he basically breaks down like what we know, what we don't know, and what works and what doesn't work. For the publication review for this week, so the this is a publication with Kevin Miller as the lead author. I'm a big fan of his work, but also I think he's one of the kind of lead researchers when it comes to this topic, specifically with electrolytes and exercise-associated muscle cramps. So the paper here, this was an evidence-based review with basically breaking down the full issue of exercise-associated muscle cramps, what it is, what seems to be the problem within the body, what structures are involved, what the physiology suggests, what treatment seems to be effective, and then also, is there anything that we can do to try to prevent this from happening? So they reviewed literature from 120-year spread, and they went through a number of different databases to find these publications. And basically, they were looking to provide evidence-based recommendations for clinicians to then diagnose exercise-associated muscle cramps, as well as manage them when they do recognize them. So, what they found, there is no one size fits all prevention program. There's nothing out there that we can tell every single athlete to do that will reduce their risk of muscle cramping. Some athletes respond well to this one thing, and some athletes respond negatively to that same thing. So really what you have to do is individualize your approach. And so they provide a 16-item questionnaire where you can really tease out what might be the biggest influences or the biggest risk factors for this individual. And so you take this targeted approach where you find these risk factors and then you go after them with the kind of therapeutic intervention that makes sense. So for example, if fatigue is one of them, well, maybe they need more rest, or maybe they need to increase their training to then better prepare them for this fatigue. So your therapeutic interventions, your treatments should align with what the actual risk factor is. Some of the findings that they found are key findings relative to electrolytes. So again, magnesium has no effect on cramp duration, frequency, or intensity. So anything that is claiming magnesium is going to impact athletic performance, yeah, probably not. Plasma electrolyte concentrations made no difference in in exercise-associated muscle cramps. And again, so these are plasma measurements where they're taking blood and they're seeing what these concentrations of the different electrolytes, sodium, potassium, magnesium, calcium, chloride, all of these different electrolytes, and none of them really seem to make a difference when it comes to exercise-associated muscle cramps. Lastly, the sodium supplementation. So this is the big question, right? Is should I take these element tablets or packets and should I mix them in with my drinks? Well, they did a study on ultra marathon runners, and they had them run, which is the longest endurance event that I'm aware of. And they had these guys go out and either they were in a control trial. So you're either taking it or you're not taking it, and then you're taking ultra marathon, and then they see what the percentage breakdown of these crampers are. Well, there's no difference on either group of the whether they were taking the sodium supplementation or not. So again, it doesn't really seem to make any impact on performance. This is the $1 million image. Basically, it's the multifactorial theory for essentially how exercise-associated muscle cramps develop. And so what you can see here is there's a million different factors. I think there's actually like 31, but there's a bunch of different factors that play here, and any one of them can increase the risk of a muscle cramp. They boil down to a common pathway, so that final common pathway, and then you get the increased alpha motor neuron excitability or activity. And then when that increased muscle cell membrane activity increases, then it results in the cramp. But there are 3 or 4 different pathways that can get you to that final common pathway. And there are different variables along the way that make it more likely that you'll kind of arrive at that final common neural pathway. So if you're increasing that neural excitability, your risk of cramp goes way up. And that seems to be what the primary cause of cramps is, some kind of an increase in neural excitability. So what were their suggestions for both treatment and prevention? They categorize these into A, B, and C letter grades based on, I can't remember the name of that classification system off the top of my head. But effectively, it's A is like highest quality evidence you should be doing these things. B is moderate or it's good, and then C is average. It's okay. It doesn't seem to be a positive or a negative, but it might have some effect. And so then the findings really in terms of treatment: apply gentle static stretching to muscle cramping. Well, yeah, everybody does that. What does anybody do when they cramp? Immediately their leg goes up and they're asking a teammate to come push their foot down because they're cramping, whether it's a calf or a hamstring, whatever. And so we already do this naturally, but it's backed by the evidence that it does relieve muscle cramps in that moment. Quinine, which is found in tonic water, should not be administered for a couple of reasons. One, it can cause GI discomfort, especially in athletic competition. You don't really want that. But then secondly, it has some implications for platelet concentration. And so you can give somebody some actual medical conditions if they're on these either medications, which are now a prescription, or if they're taking a large concentration of things like tonic water, and they're on it for a long duration of time. In terms of highest quality prevention, yeah, there's not one. So we don't really have a great prevention plan. The best suggestion that they gave is, again, that individualized targeted approach where you find the individual's risk factors and you kind of try to go after those. But there's not a blanket prevention A grade evidence. For the B tier suggestions for treatment, acetic acid, also found in vinegar, or capsaicin can be used infrequently and in small quantities. For whatever reason, there seems to be some kind of a neuromuscular trigger where this touches the tongue. You don't even have to digest it, but it touches your tongue. And so this is where things like pickle juice comes into, where you get the flavor or you get the acidity, and that triggers some kind of a neuromuscular relaxation for whatever reason. But the pathway is not that well understood, but it does seem to have some effect in relieving cramps once they exist, but it's not a preventive treatment. In terms of prevention, B-grade evidence, incorporate neuromuscular reeducation, plyometrics, or strength training if neuromuscular fatigue is identified as a risk factor. So again, you go back to that individual pathway. If neuromuscular fatigue seems to be an issue, then you need to train effectively to prepare them for their competition. Similarly, you need to be training at intensities and conditions. So these are environmental factors, temperature, things like that, or duration, similar to competition. So if your competition is 90 minutes in a soccer game, 60 minutes in a football game, you should be training for at least that long. If you're going to go out and play a game outside when it's 103 degrees, then you should be training out there in that same weather. You shouldn't be training inside in a dome where it's 75. So that'll wrap it up for this week. So just a reminder, what are electrolytes? These are minerals that have an electric charge, whether they are positive or negative. Those things impact the body through their electrical charges, and these are sending effectively neural pathways or neural signals that are going to have different functions throughout the human body, and their influence on performance is pretty negligible. We don't really have much evidence that suggests they do anything other than maybe rehydration. So for the next meeting, we'll break down specifically with electrolyte-associated muscle cramps, what the risk factors are, and we'll get into that pathway that we talked about in this study in a little bit more detail and depth. And then we'll talk about the different influences and variables that you can control for once you've taken that individual through that questionnaire and found some risk factors. Hope to see you all there, and take care.